In a city, reliability is important in many different ways just because of the density of people. If a pole or a wire goes down, that's not just affecting, one house in the woods. That's affecting hundreds of thousands or millions of people.
Particularly in densely populated urban areas. Dense housing, limited space for things like rooftop solar, EV chargers, plus lots of growing power loads.
Tools that are available to dense urban residents is much narrower, and yet the need for flexibility is much more concentrated for these utilities.
Why this drop shipping strategy is the strategy that seems the most promising to you.
Our batteries are very similar to the way that smart thermostats have performed over the past, really 10 years. And so you need grid flexibility to address grid congestion. What often you can do is do more with what you have.
Hey everybody, and welcome once again to Power Perspectives. I'm Kinsey Grant Baker, and I have a question for you. What if we could drop ship grid flexibility in big cities? And if we could, might that be the solution to our shared dilemma of overworked, undercapitalized power systems in these densely populated metro areas? Today, we're going to figure it out together, because grid flexibility is increasingly becoming a must-have for utilities, especially in big cities where the grid has to be a lot of things for a lot of customers all of the time. So what are the tools necessary to rethink what the grid looks like? What are the roles end customers can play? And how do we do all of this at scale? To answer those questions and plenty more, I'm excited to welcome Andrew Wang, co-founder of Every Electric. Every Electric is a startup that gives people batteries to monetize grid flexibility from everyday load. We're going to talk about the challenges of grid flexibility, this idea of drop shipping it directly into homes, and of course, what comes next for some of the cutting edge tech that is redefining our efforts to work smarter on grid modernization. Andrew, welcome to Power Perspectives. How are you today?
Doing great. Thanks for having me, Kinsey.
Of course. I'm thrilled for this conversation. You've got a really cool thing going here. We're going to dig into some of the more specifics of the work that you and your team are doing for sure. But I want to start this conversation by really just getting, a little more granular on defining this challenge of grid flexibility. To the extent that it's possible, I would love if you could just kind of sum up this obviously very major issue. What makes grid flexibility such a pressing issue for power pros today?
You need grid flexibility to address grid congestion, right? So in this new era of rapid electrification, of rapid load growth, sometimes you can either increase the supply, but what often you can do is do more with what you have, right? And so how do we adjust the way we as ratepayers or the way that utilities might incentivize way ratepayers use power to better match what's available? And if we can better use that electricity more efficiently, right, that translates into lower cost and higher affordability and reliability, which are all sort of great things.
Yeah, I think that's a really masterful way of putting it in a few sentences. I think that just reiterating that idea that grid flexibility is the solution for grid congestion. A lot of the conversations we have on this show are really rooted in that idea of congestion and infrastructure issues and challenges in terms of build out and what comes next and how do we incentivize the right things and where do we deploy capital. All of this is really focused very closely on grid congestion itself. So I really want that to be the base of this conversation, the root of this conversation. And then getting a little bit more into the weeds here, when we're talking about grid flexibility and grid congestion as well, particularly in densely populated urban areas, I understand that this kind of becomes a little bit more of an issue. Dense housing, limited space for things like rooftop solar, EV chargers, plus lots of growing power loads. I'm saying this coming to you live from Brooklyn in New York City. So talk to me a little bit about what some of the challenges are when we're looking at grid flexibility specifically in these urban areas.
The one thing with grid flexibility, again, is it's tied to allowing the grid to operate more efficiently and more reliably. And so in a city, reliability is important in many different ways just because of the density of people around us, right? So I'm also here in Manhattan, across the river from you, Kinsey, and if a pole or a wire goes down, that's not just affecting one house in the woods. That's affecting hundreds of thousands or millions of people. And so reliability is really important, but that comes at a cost of maintaining the grid. And so in many ways, if your grid can be more flexible, it has a far higher impact in allowing that grid to work in better ways for even more people.
And I'm curious to know a little bit more how you see utilities, power companies that exist right now that are doing their best to serve these customers, knowing that they have customers who are in these more densely populated urban areas, customers who might not be in cities but might still have very specific needs for power. How are they attempting to serve these more complex regions? Can you tell me a little bit more about their approach to flexibility or how that might shake out?
Utilities work with many partners to I guess enable grid participants and ratepayers to become more flexible. So one of the big things that listeners might understand is maybe you own an EV, and the utility can give you a special plan where if you charge it in the middle of the night, you get cheaper electricity. Or there are a lot of distributed energy or renewable companies that offer rooftop solar installations and rooftop solar services. And so, in many parts of the country, these are really mature technologies, mature industries that are now seeing, rapid adoption. I think one of the unique things in the city is that, when I moved to New York, I moved into my shoebox apartment. I don't own an EV. I can't install solar. I don't even have a roof, right? So that the tools that are available to dense urban residents is much narrower, and yet the need for flexibility is much more concentrated for these utilities. Yeah.
Yeah, it has been something that I have felt candidly a little frustrated by as I get further into this industry and understand the role of the customer and the role that I could potentially be playing in terms of grid flexibility and helping build out this modernized grid of the future. But I rent, right? Like and I don't have a car, as you're mentioning. There are a whole other set of circumstances for people who live in cities where we don't necessarily get to participate the way that we might want to. And I think this is one of those spaces too where it brings up this idea that for all of the promise of DERs, of distributed energy, there are still some shortcomings. Do you feel that this is sort of one of those shortcomings that this might not be enough, especially in these urban areas?
Our electric grid is shared infrastructure. And when the tools of flexibility are, say, not necessarily well distributed, those that can flex, be it the EV owner or the single family homeowner that can install a full home backup batteries or rooftop solar, they have the ability to access lower power prices, right, on average. But me and you, and for the majority of dense urban multifamily residents, here in New York City, we're stuck. We have no way to shift the way we use our energy, and so we thought it was really important to be able to develop solutions that work for this class of renters that might move every summer, or multifamily cooperative buildings and whatnot. And so this is a big part, particularly here in New York. That's a big part of the grid, and so it's really important, both for us and for the utility to have a way to incentivize those folks to become sort of interactive assets and contribute to the grid operating in a better fashion.
So now, Andrew, I want to talk a little bit about your preferred approach. For all of the money being put into DERs, it is really promising tech, but it might not necessarily be promising for everybody using our power systems all of the time. So let's talk about Every Electric. You guys are using this idea of drop shipping batteries versus these more sort of whole building retrofit kind of infrastructure projects. I would love to understand a little bit more about number one, the work that you're doing, and number two, why this drop shipping strategy is the strategy that seems the most promising to you.
Yeah, so I think we're at a stage in the sort of technology curve where the actual hardware of batteries and energy storage has sort of followed that same pathway as solar, where the technology itself has become so cheap that the most expensive part is actually getting the paperwork and then sending the person out to do the installation. And that's even more of the case here in the city where you don't even have the space or the sort of environment to be able to do the install even if you had the money. And so it's very, very hard to install anything from residential through to utility scale storage here in New York or dense urban grids. And yet at the same time, I look around me and I'm surrounded by batteries, right? I'm talking to you on a laptop. I have batteries in my earphones. My vacuum cleaner is a lithium ion battery that's plugged into the wall, right? And so that's a grid connected battery. And so our fundamental idea is, what is the smallest battery that we could ship like a consumer electronic product to each household, allow them to plug it in, get away with the installation and the permitting, and still have a meaningful impact on what's going on the grid. And so that was sort of our solution, is to provide you essentially a large portable phone charger. Right, you go out, you have a phone charger, you have a portable battery pack, but now we're using that battery pack to basically enhance the way that your everyday appliances are drawing power from the grid, allowing you to shift that load.
So I'm curious to hear a little bit more how, how this scales. If we're talking about household by household, I'm sure a question that a lot of the people listening to this might have is, we've got some promising tech. We can get into how we get people to use it and how we encourage, and incentivize them. But I think the question to start with is just how and where does it scale? Can we start with these by household and then scale into something that feels grid scale? Is that a possibility? And is that kind of the path?
Yeah, yeah, absolutely. So it really depends on what you plug into it, right? So, for one of the things that we wanted to address with our batteries is it's hard to get, an interconnection permit, which means it's hard to send power back into the grid. So what can we plug into the battery that doesn't send power back into the grid, but can still effectively take, a meaningful amount of load off the grid? And so, here in the city, every summer, I turn on my air conditioner, my window air conditioner, and I know my utility bill instantly doubles, right? Um, you've probably had this experience as well. If your bill doubles, what does that mean? That means more than half of your household electricity usage runs through, the air conditioner. And here, in New York, and a lot of, particularly in the East Coast, where you have, an older built environment, you do not have a lot of central air conditioning. 70% of buildings were constructed before 1950. You have a lot of these old legacy plug-in window ACs. And so that was the sort of first sort of wide scale appliance that we wanted to pair our batteries with. And in New York, for example, uh, these window air conditioners make up 20% of Con Edison's utility, peak capacity. So it's over 2 gigawatts of summer load. And it's perfectly coincidental with when the grid is most congested, right? And so we really went with, every household on average has two of these appliances. If we can get a battery next to each one of them, we can turn these, liabilities on the grid into assets that utilities can operate and dispatch, and make the grid a little bit easier to run.
Yeah, it's super interesting to hear those stats too, as a New Yorker for many years who has had that exact experience of seeing my bill double as soon as I turn that AC unit on for the first time each summer. Now, I think this brings to mind an interesting question about incentivizing use, right? Obviously, if it's going to help your bill stay a little bit lower, if you're going to avoid that experience of seeing that bill double in the months from, May to September, that feels like a pretty good incentive. But sometimes price alone is not necessarily enough for customers. So I would love to hear a little bit more about, you got this great tech. How do you get people to use it?
We actually have an interesting model where the utilities are actually our true customer. So, in the same way that a solar developer, if you're a farmer, a solar developer might lease your land, give you solar panels to put up, and then sell power to the utility. We're now taking that same, renewable project development model towards sort of dense urban DER deployment. And what that looks like is, we buy these batteries, we drop ship them to you, and we effectively lease your air conditioning usage for us to flex, and we sell that flexibility to utilities like Con Edison. And so that's a model that allows us to provide the batteries at low to zero cost to the household. And that really shifts the calculus on, which households, and the decision around adopting new technologies like this. And so, in many other parts of the country where you might be installing whole home backup, you have to decide between, a $20,000 lease, and what it would do to your home price. And you're not sure if the OEM will be around, to maintain a warranty. For us, because we can provide that for free, you're really a partner in us providing that reliability service to the utility. But yeah, in the summer, obviously you have a lower, you end up having an effectively a lower utility bill, but you also get all the other benefits of having a plug-in battery at home, right? So the unique part of this is For Con Edison here in New York, the grid is actually extremely reliable. There are almost zero blackouts, and so you know, nevertheless, the battery can still provide backup power as a perk. So it might not be the first motivating sort of decision to adopt the solution, but even last summer in 2025, through no fault of the utility, we had flash floods, building level outages, and we had participants' households that were able to still, now they have a battery. You can plug your router in, continue working from home. And so, there's the reliability aspect. And then obviously the community benefits aspect, right? So, I feel a bit of guilt if I'm turning on my air conditioner because I know, it's going to hurt my wallet and it's also going to run a dirtier grid during those peak hours of the day, right? And so the sort of community benefit, the emissions impact is the other aspect. Is that by reducing your load during those peak hours, you're reducing the utilities usage of peaker plants, which could just be down the road for a lot of our participants, and is directly contributing to a clean air environment around it. So it's really those sort of three key aspects I'd say that has really resonated with our customer base.
Yeah, that makes a ton of sense, and you bring up too this tie-in with, Con Edison and working with the utilities directly. I would love to hear a little bit more about, what that real world implementation looks like. So tell me a little bit more about the relationship with Con Edison, and I think crucially, how you get a utility on board when you have something that's like this. It's a, promising new tech. It's a little different. It's a different model than people might be used to. It's a different model than the utility might be used to. Talk to me about what that relationship looks like and how it came to be.
Yeah, so Cognizant has been an amazing partner through and through with deploying the solution. Um, I think one of the unique aspects is we tailored the way that our batteries work to be able to deliver demand response, right? So be reducing energy usage when it's called upon, in the same way that traditional sort of demand response and traditional technologies have done so in the past. From Con Ed's perspective, our batteries are very similar to the way that smart thermostats have performed, over the past, really 10 years. And so a lot of groundwork was already laid for us to be able to, for like a speedy adoption from, we sort of skipped the piloting and just became an official aggregator with Con Edison in our very first year of deployments. And a lot of that was because a similar technology was already deployed for the past decade. Now we're just coming in with energy storage that amplifies the efficacy of that demand response. And so they've been great, as both co-marketers to ratepayers, but also having that infrastructure built out that is able to quickly both measure, verify, and incentivize innovative solutions like our own.
Yeah, totally. As we're talking about what this partnership looks like, what it looks like to deploy this with customers, ratepayers, in the summer months and throughout the year too. One of the questions I would love to hear your perspective on is potential constraints. There are many, many parts of this country where people don't have window AC units, where they might not necessarily be living in urban areas quite as densely populated as the one that the two of us call home. I would love to hear a little bit more about, how this drop ship model or a model like it might scale in other parts of the country and other parts of the grid that might have different needs. Can you tell me a little bit more about that?
You're completely correct that this is, particularly effective in congested grids. But congested grids, that is something that is true, whether it's from a system perspective or a geographic sort of built environment perspective as well. So yes, that's cities like here in New York, but it's also, islanded and isolated grids as well. And you have to remember, this is a plug-in battery. It's a standard, you know, US plug, and every plug across the country uses this exact same plug. And so human behavior is pretty generalizable. We like to be comfortable and use the air conditioning, or we like to turn on the heat when it's cold. And so across the country, I think in terms of what loads the battery can service, is really well generalizable. It's really about what the grid needs, how much flexibility does it need, how quickly do we need it deployed. And I think what really stands out for our solution is we are, you know, very fast to deploy, self-installable, and through, many cuts, paper cuts, I guess, addressing this problem of, load growth and sort of reliability. And so for us, it's an undeniable trend that battery technology and energy storage is universally effective and will diffuse through our energy infrastructure. But the sort of scale of the exact size of the battery will change from market to market. So, for example, California and Texas, you have a lot of utility scale storage. It's about like 2 kilowatt hours per person. But in New York, in a lot of the East Coast, why is that number only around 0.1? It's really because of the nature of the grid, the nature of our built environment, and it just so happens, each one of our batteries is about 2 kilowatt hours, and so, I think we humans need a certain amount of buffer in terms of the energy we need. How that manifests itself on the grid needs to be optimized to the different markets that we're in.
I would love to talk now about thinking this through at the grid scale level, at the, country scale level. How might this impact customer equity overall? A big conversation that everybody in our industry has been having lately is prices and equity and ensuring that the right, entities pay for the right things that they need from the grid. Does this idea of flexibility broadly speaking, but also this more specific drop shipping flexibility, does it change the perspective on customer equity? Is this a potential tool for customer equity? And if so, how?
Yeah, it absolutely is. This is a solution that works particularly well for renters, for multifamily residents, and a lot of that fits what you would find the type of ratepayer in LMI communities, like low medium income communities, and so a lot of the technologies and solutions around distributed energy today, are not accessible to all, right? Whether it's, you live in the city, it makes no sense to own an EV, or you don't have a roof to hang a solar panel on. How do we get the tools of flexibility into the hands of, more people? And so, this is something that is in line with what utilities need as well, right? They need more grid flexibility to come online. Um, and in many ways, the solutions that we have right now, um, allow those can access the shiny new big, battery or solar panel or heat pump or whatnot, to benefit the most. And so our approach, I think, is particularly important in that, the only other way of incentivizing grid flexibility is through behavioral change. And day three of a heat wave does it. It feels a little bit unfair to be spam texting someone telling you to turn your air conditioner off because you should be helping the environment when I have no other thing to, when there's no other solution. And so, you know, by drop shipping batteries, you can plug the battery in, you can ignore anything asking you to shift your, reduce the amount of energy you use, because we're automatically shifting that energy on the back end.
It's a great point. On that day 3 of getting text messages, they start to get a little old, I can imagine for a lot of people listening to this. So, Andrew, as we finish up here, I want to talk a little bit more about this bigger picture of the future of grid flexibility at an industry level. I think a lot of the conversations that we have about grid flexibility today, they feel pretty rooted in more modern developments. A lot has happened over the last several years. A lot will continue to happen over the next several years and certainly beyond that. What do you think the future of grid flexibility looks like? And that's a pretty open-ended question, but what's kind of your vision for the future of grid flexibility as a necessity for the utility professionals listening to this and for the grid itself?
The future of grid flexibility needs to sort of bring everyone along as stakeholders that have some kind of buy-in in the solution set. So I know a lot of conversations around grid flexibility are centered around, data centers, right? That's the hot flashy topic around how do these large loads be flexible. But really, you have to remember that there's also human centers that matter a lot, as well, and these are it's the human centers that vote. It's human centers that like drive policy change. And I think you sort of have to cater to both, because it's really the people that pay their bills every day that feel the most, whether rightfully so or not, right? Like there are changes in the grid, there are changes in the way that we use technology and use energy around us, and the grid is this massive shared infrastructure that you know can't compromise on reliability, but has to keep up with the way that our everyday behavior is starting to shift. And I think the key to keeping up is really grid flexibility, and a key is really activating a lot of those ratepayers that have traditionally been left out of the grid flexibility story. And so that's something that we're really laser focused on.
Yeah, it's a great point. It's not all data centers despite what we might read and hear and frankly talk about on this show often. So it's a point well taken too. As we're thinking about the ways that, taking lessons and ideas from a conversation like this might materialize at a utility, what would you suggest to the utility leaders and decision makers who might be listening to this episode to help them really ensure that grid flexibility remains a top priority across, their markets, across their businesses? What's your advice for utility pros?
You know, grid flexibility and distributed energy resources sometimes go hand in hand, and it's important to I think some of the shortcomings in the past has been how dependable is this resource? If I ask people to dial their thermostats up, 1 or 2 degrees, or to go out for a walk to turn the air conditioners off, you know, if I'm not 100% certain that that resource will be there when it's called upon, then I can't ascribe a certain value to that grid flexibility, right? Because reliability, you can't compromise on that. I would say that a lot of the technologies that are coming onto the market that are starting to be, distributed to ratepayers, like batteries, sort of solve a lot of that sort of dependability, um, uh, question. And so, I think you can start placing more confidence in the ability of these flexible resources to be there when you need it to. And I think that's really something that we've been quite excited by, and a lot of the utilities that we're currently working with are excited by as well. And so it's also a great way to sort of get ratepayers accustomed to these new technologies that are coming around. So when you have a battery that's operating in your home, saving you money every day, now you become more supportive of these new initiatives of larger batteries out in the distance that also are going to help improve the reliability and sustainability of the grid. And so I think it's really a collective effort, both at the very very small, ultra distributed, behind the meter, behind the plug, all the way through to utility scale. I think these are all things that are becoming more and more bankable. You can sort of rely on these things to be there when you need it to.
Yeah, a wonderful piece of insight there. All right. So, Andrew, now we are ready to transition to our lightning round. This is the part of the podcast where I'm going to ask you just a handful of questions here. We try to keep it super quick and rapid fire to close us out. So, my first question for you: if you did not end up where you are today, starting Every Electric, what is an alternative career path that you might have taken?
Yeah, I started my career in like how the ions in the batteries move from the positive to the negative side. So I think in an alternative career, I would still be sort of nerding out about the sort of minutia in the electrochemistry in the batteries.
I love it. Is there a common misconception that you might have about batteries that you would like to clear up? What are people not getting right?
Honestly, like the batteries that we have today are great, and they are great enough for usage already. I think I say just don't get too hyped up about some headline on like Yahoo News about the next generation battery. Like the technologies we have here and now are already helping us in our daily lives.
All right, I love it. And my last question for you, do you have any advice for any of the startup founders or innovators who might be listening to this episode? What would you tell them based on, what you have learned throughout your journey so far?
Yeah, I mean, I think it's finding ways to create immediate value. For us, we went from scoping out utility tariffs in February to deploying batteries in May to paying every, ratepayer in our program over a month's worth of free electricity in October. And so, find a way to, build those rapid cycles to learn and get feedback and scale from there. So I think, the market really demands that of us at the moment.
All right. Wonderful way to close this out. Andrew, thank you so much for joining me on Power Perspectives today. It has been such a wonderful conversation talking about the big picture, talking about the innovative work that your team is doing. And I'm really, really grateful for your time.
Awesome. Thanks so much, Kenzie.
And thank you to all of you for listening. Once again, this is Power Perspectives, and I'm Kinsey Grant Baker, and we'll see you next time.